All right, we're live. Another episode of Monero Talk. We're with Howard Chu. Um, you're one of the core devs, is that correct?
I guess you can say that. I don't know if there's actually a title of core dev, but yeah.
Okay. So I mean, I think there's a ton of things that we could actually talk about. I have lots of questions, but I guess I wanted to focus on the randomJS proposal that you've recently been discussing. Are you the originator of this concept?
Let's see. Well, there was, it actually came off of another Reddit thread. Um, so the original suggestion came from someone else, but I kind of took it and ran with it. Yeah.
Cool. I guess before we get into it, I know you don't have a lot of time, so I don't want to spend too much time going into other questions. But I guess maybe just a quick background. I know you have, an interesting background in Open LDAP. I'm
All
not
right.
very familiar with it, but I assume there might be some connection to that world and how you got into the crypto world.
Okay. Well, so OpenLDAP is an open source directory project. It's heavily used in enterprise software. Um, we actually just had our 20th anniversary this past fall, or this current fall, actually. Yeah. And I've actually been working on that project almost from the very beginning, so 20 years on that. The connection into cryptocurrency is kind of indirect. I mean, I've worked on a lot of cryptography software before. I've worked on OpenSSL for several years, and I've worked on Kerberos and a couple other projects. But the connection here came through LNDB, the database engine that I wrote for OpenLDAP. And that became the database that the Monero guys selected for their blockchain.
Okay. So were you interested in Bitcoin as well before that, or is that what kind of brought you into crypto?
Yeah, I completely dismissed Bitcoin when I first heard about it. I said, this is a linear data structure that they expect to have global reach. It'll never scale. It'll never work. And I just said, nah, this is garbage. So I completely ignored it. And I only got into cryptocurrency because of the Monero project reaching out to me to use LMDB. Yeah.
Hmm. Now, so has your opinion of Bitcoin changed since then, or how? I mean, obviously it's changed in some way, but what has kept you kind of in the Monero world versus being pulled into the Bitcoin maximalist zone?
Oh, well, it's obvious, right? Bitcoin is not fungible, and Monero is. For all these projects that call themselves cryptocurrencies, none of them live up to the name. Crypto means hidden, and currency requires fungibility, and none of those other projects amount to that. Bitcoin or any others.
Yeah, couldn't possibly agree more. Um, so I guess if you want to jump right into then the ASIC resistance, maybe if we could give just like a quick little background on that. Um, why do you think ASIC resistance is something Monero should be striving for? And what is it essentially? What are we trying to achieve with that?
Okay, well, I think it was actually spelled out in the original Kryptonite white paper. Um, the idea is, if you look at how CryptoNote started, it's obviously was written by people who had observed Bitcoin over the course of years, and they saw that Bitcoin mining had become heavily centralized in a couple of mining pools, whatever, all based in China. And that centralization was largely fueled by the development of ASICs for Bitcoin mining, right? Um, and so if you follow this in the CryptoNote paper, the basic point is when you allow ASICs to dominate your currency, you've got a very strong force for centralization, because not everybody can access these ASICs. The people who are manufacturing them tend to hoard them to themselves preferentially. So there's no egalitarian access to these things, and so that really does violate one of the principles a permissionless blockchain where you want everybody to have the ability to use it. Centralization really harms that principle.
Do you think Bitcoin has become more centralized over? Is this something that we could actually measure that we know is actually happening? I mean, are
Oh yeah,
ASICs actually having this negative effect of centralizing things?
absolutely. In fact, if you look, if you follow Emin Gun-Sirer, he's been a crypto developer for quite a long time, and one of his writings over the past summer was showing centralization both in Bitcoin and Ethereum. They actually measured the number of mining pools, the geographic distribution of them, and a couple other factors, and you can see that Bitcoin is highly centralized. Ethereum is centralized too, as well, to a large extent, but I think Bitcoin more so.
Is it fair to say Monero is seemingly one of the most decentralized coins? I mean, large cap coins.
I think at this point, probably, certainly we've paid the most attention to, encouraging decentralization.
And now, so what do you think long term overall? I mean, I feel like even within the Monero community, there's kind of a few different ways of looking at it. Is it that we want to, the goal, I guess, is we could all agree is to be as distributed as possible. Now, does that necessarily mean we always need to stay ASIC resistant, or is there a possible future where ASICs eventually do come in, but in such a way where we can maintain our distributed nature?
Yeah, that's an interesting question, and most people believe the latter, what you just said, that in somewhere down in the future, ASICs will become common enough and accessible enough that we don't have to worry about resistance anymore. Okay. Now, I look at that and I'd say the average user or consumer, isn't going to go to the store and buy an ASIC box. No matter how easy they are to get, they're not going to do it. It's not anywhere on their radar. So the only way this happens is if whatever this acceleration chip becomes is already bundled into a device that they already care about, like a cell phone. So until that point, decentralization with ASICs is not going to be a reality. All right. So, people talk about that. People talk about that right now, saying, "Oh, there's more companies entering the market, building and selling ASICs," and so this is already promoting decentralization, and I think that's false, because the average miner or the average user, crypto coin user, isn't going to be on board with those.
Right. So, because you're saying because of the nature of the ASIC, which is specialized hardware, which it can
Yeah,
only really be used for proof
for
of,
one
proof of
purpose.
work, that
Yeah,
it's really never going to become a part of our daily technology.
exactly. I don't see that happening.
Now, I think there's arguments that are being made that that's what makes ASICs. I've heard things, game theory arguments that's kind of a positive for ASICs. Because if ASICs can only be used for mining, then there's no incentive to use them to harm the network, because then it's like you get you don't want to kill the hand that's feeding you, right? So then
Right.
if you use them to attack a network and then essentially end up killing the network by whatever it is, 51% attack, whatever, then at that point, game theory wise, what are you going to do with all these ASICs if you can't use them for something else?
Sure. Yeah, and that's probably a valid argument in the long run, but it's not. It's not an airtight argument. If somebody says, "Oh, we now have 51% of the network, but we don't want to kill the network because it would harm our profits." Still, once in a while, Big Brother might come along and say, "Hey, would you please, divert this transaction or censor that one?" And in one-off instances, that could happen without anybody seeing. So Yeah, in the long run, they don't want to kill it, but that doesn't mean they won't poke and subvert it occasionally.
Mm-hmm. Right, and it's just theoretical.
Yeah.
So how is that conversation going then in the community? I kind of the inner crowd, the guys who really understand this stuff, and that are kind of really making, the policy decisions. Where are people at then overall? Are there people leaning then towards this? We should aim to stay ASIC resistant. Is that kind of catching fire a little bit?
I think for the near term, that's definitely the case. Yeah, nobody nobody thinks within the next 6 months or next year that ASICs will be commoditized enough. So yeah, in the short term, definitely we're still fighting that.
And then so the next question becomes, and I guess this is where randomJS, I think, starts to become part of the conversation. Do we hard fork every 6? I mean, that seems to be the case, right? We're doing these upgrades every 6 months. Do we fight ASICs off in that manner, or is there something else that needs to be done to?
Okay, yeah. So Monero already does an upgrade every 6 months. That's just normal, right?
Mm-hmm.
So what was unusual on this upgrade and the previous one is that we changed the mining algorithm each time. Now, I believe that's not a sustainable model going forward. We can't keep on doing these minor tweaks to the mining algorithm, partly because it's hard to do these tweaks. We have to keep them secret almost to the last minute, to the last day before the release, to make sure that no manufacturers get a head start. It's awfully easy to make a mistake, and suddenly we have a mining algorithm out there that has a backdoor or a shortcut that we don't know about. Yeah. So there's a danger in continuing the approach that we have. Now, obviously, these first two upgrades, the first one, we did as quickly as we could a little tweak that would break any existing ASICs, and that was its only purpose. We knew this is a very small tweak, and any hardware manufacturer can easily patch it into their next board revision. All right. The second tweak is a little more extensive. It would take a little bit more work for an ASIC designer to accommodate it, but overall, neither of these is designed to prevent ASICs coming in the future. They're simply, point fixes to break the existing ones. And I mean, I don't believe that's a sustainable way to keep developing. So we're looking for a proof of work that will last long term. Like Kryptonite lasted for 3 or 4 years before ASICs finally came around. So we're looking for something else that'll also last for at least 3 or 4 years.
So since the most current hard fork, and looking at that, was there any drop in hashing power there? Were there suspected ASICs to even have come on since the previous fork?
Okay, there was a drop in hashing power. I don't think it shows signs of ASICs. All right, it's just that with the new tweaks, the algorithm is like 10% slower on a lot of CPUs. It's 5 or 10% slower on a lot of GPUs. So there is a noticeable drop, but there's nothing like the drastic decline we had after the previous upgrade, where half the hash power disappeared.
Right, and it was very evident that there were ASICs, considering they then forked off and created their own coin.
Exactly. Yeah. So there's no evidence that happened this time around. Yeah.
Do you keep your eye on that at all? The other Monero coin that's sticking with ASICs, is that something that's even relevant in the community that people are looking at to see, or is it?
I haven't really been paying attention. I think once in a while someone will poke up and say, "Hey, I just looked at that and nothing's happening." So as far as we can tell, all of those other, the groups that decide to stay on the old fork have pretty much died off.
So then what is randomJS? How is this now going to potentially be a, more of a long-term solution where we won't have to continually upgrade the proof of work to avoid the ASICs?
Okay, well, basic idea, the reason that an ASIC is so much faster than a CPU or more efficient than a CPU is that it's only doing a single job, all right? And a CPU is designed to do anything, right? It's a general purpose processing unit. So what we want is something that's more complicated, something that's too complex for a single purpose chip to execute. All right, that's one of the conditions. The other, and along with that, is something that uses features that CPUs have that current ASICs didn't need to have yet. All right, so the idea kind of is, if you were going to build an ASIC for this, we're going to force you to make it into a CPU. All right, and once we've done that, once we've said you need a CPU to be able to perform this proof of work, then that puts everybody on more of an even surface. And now the thing is, any simple algorithm you design, if you can describe it in like a paragraph or in a page of code, that can be trivially turned into an ASIC. Right. Any single algorithm that you go with can do that. And there are other proof of work systems out there where they combine like a dozen different hashes, or they sequentially run different algorithms. And in every case, an ASIC can easily be built for that, because you're talking about a small number, a finite number of algorithms, and each one of them can be designed and burnt into a circuit, and then hooked up in any sequence they want. All right. So the problem that we're trying to solve is, how do we come up with something that isn't a single fixed algorithm? And so that's where randomJS comes in to say, well, we're going to randomly generate code, right? So there is no single algorithm that anybody can burn into hardware.
Now, is this a new concept overall in the the computing community, or has randomJS been used for maybe in some other way, in some other fashion in the computing world, or is completely novel?
Well, I guess okay. The code that I started with as the proof of concept was a program to randomly generate C code, and that was actually developed to test C compilers, right? To try and exercise them and surface any bugs in the compiler. So this kind of random code generation as a tool has been used before. I don't think it's been used before in cryptocurrency proof of work.
And so why randomJS? Because I guess there's other things I've heard that kind of are similar in concept, but doing it in a different way. Like programmable proof of work. Is that
right?
What would be the comparison there?
I actually did some discussion with those programmable POW authors as well. So there's a couple key differences. The ProgPow guys are focusing on GPUs, all right? So they and the algorithm that they've got would run poorly on a CPU. Okay, so that's one of our key differences, is that I'm still focusing on CPU support. The other thing, most of their algorithm is based on eth_hash, and still looks a lot like eth_hash. And so the part that does random code in their algorithm is actually fairly small. Okay, and they're only talking about 16 randomly selected instructions, or a set of 16 instructions that can be randomly strung together. And if you look at that from a hardware designer standpoint, you say, well, integrating 16 operations in a chip is easy. So I don't think that what they're doing is really going to deter any ASIC builders. The reason I chose JavaScript is because it's a fairly large language, it's a very complex language, and to embed the entire language on a chip would be difficult. It would use up a lot of chip real estate.
Yes, I mean, maybe this is a real theoretical question. So what would have to happen in terms of technology to reach that point where randomJS would no longer be able to thwart an ASIC or prevent the building of an ASIC? On a technology level, where would we need to be?
First of all, I have to say that there are shortcuts that we know about now that might render this not quite a viable approach. But if we just take it at its face value of, how do you accelerate JavaScript? That's a problem that web browser companies have been working on for 5 or 10 years now. Okay, so I'd say it's a difficult problem on that face. There probably aren't any big breakthroughs that are going to happen. Okay, if something did happen, that could actually be a huge win, because then maybe we'll see JavaScript accelerator chips in smartphones in 5 years from now. That could be great. But the fact is, the language itself is one of the more awkward, ungainly ones to implement in a computing system. So I don't see JavaScript itself being something that anybody comes out with a breakthrough with anytime soon.
Mm-hmm. And now, but you saw there's other issues that we have to worry about?
Okay, yeah, so we've been actively discussing this for quite a while now. One of the issues that surfaces is, well, there is no reason for an ASIC developer to actually execute JavaScript. All right, they could take the random generator and modify its output to just modify pure machine code or something that's very easy for them to execute. Okay. Now, in our algorithm, we do require JavaScript source code to be generated, and we check for that by running a hash on the output. Right? So if you submit a proof of work solution and the hash doesn't match, then we say, well, you didn't generate valid source code. The thing of it is, even though you generate valid source code, there's nothing requiring you to execute that source code. If you generate source code and machine code in parallel at the same time, and you only execute the machine code, then you're kind of short-circuiting our algorithm there. And so this is one of the key problems we're focused on right now, is how to avoid that shortcut.
So do you think this is something that could be solved then and overcome, or I mean, where do you see randomJS going?
It's not really clear right now. It may be that we don't use JavaScript in the end, and we actually use machine code ourselves, because at that point, the shortcut is equivalent to the main code, right? So then there's no further execution advantage there.
So what kind of support are you seeing in the community for the the general concept, if it could be tweaked correctly?
Well, I think there's a lot of anticipation and interest in the concept. Yeah. Obviously, we need to. If you look at how Bulletproofs got deployed, Bulletproof code was available on testnet for over a year, and then it was forwarded to 3 different independent auditors. And so we waited for all 3 of those auditors to come back with their full reports before anybody would say, okay, let's deploy this on mainnet. And so that kind of scrutiny is going to happen here as well for for randomJS.
So would that kind of be next step then, to maybe move something to testnet, or we're not really near that stage yet?
We're not really near that stage yet, but when we do get something onto a testnet, then we're probably going to start looking for auditors and reviewers. Yeah.
Cool. So what do you think? Any other thoughts on randomJS before I start asking you other questions?
No, I think that covers it for now. Yeah.
So I guess since I have you, I'd love to be able to kind of hear your view on Bulletproofs now that we have them. I mean, I think it's a no-brainer that it's obviously it's working and it's a great thing.
Yeah.
But I think that one of the questions I'm seeing, and maybe this is an obvious one, but how much more, if, or the question that's kind of being posed, with Monero's dynamic block size, and now we have Bulletproofs. Basically, if Monero had the same transaction volume as Bitcoin today and was at the price that Bitcoin's at today, just trying to quantify and compare Monero to Bitcoin in terms of, its efficiency and transaction price, kind of an apples to apples comparison. Where do you think we would be at? So if Monero had the same transaction volume as Bitcoin today and the same price as Bitcoin, would our transaction fees be comparable to Bitcoin? I know it's kind of a hard question,
that's an interesting
question to answer on the spot, but just trying to.
The way the fee mechanism works, as usage of Monero goes up, the per byte fee actually decreases. So there's a strong chance actually that the Monero network would be cheaper to use, right? As far as having equal transaction volume, Monero transactions are still larger than vanilla Bitcoin transactions. Okay, so that would impose a lot more network bandwidth requirements, and it's not clear to me that all of the people using it right now have good enough internet access to sustain that. I don't know the answer to that one. Mm-hmm. But aside from that, the per transaction fee would certainly be lower.
Yeah, I think that's certainly an exciting thing, and I think it's something that people, because with Bulletproofs it was overnight. You woke up the next morning and you went to send the transaction, and it went from whatever it is, 30 cents down to half a cent. Right. Whereas with the dynamic block size, I don't even think people are realizing the potential benefit there. I mean, obviously, people in the know are, but I mean, for the casual crypto user. It's pretty interesting that I feel like it's not being even talked about enough as to how Monero is built to scale and is made to, the more transactions, the better, which is
right.
an important feature to have.
Yeah, if you want things to actually be usable, yeah.
Do you think Monero is better architected then in terms of scaling than Bitcoin is at its protocol level?
Yeah, I do believe that. Yeah, simply the fact that we do have dynamic scaling versus a fixed block size. Yeah, that's going to go a long way. It's not having a huge impact, this week because transactions are so much smaller now that the blocks aren't. We don't have full blocks at the moment, right? There's not enough transaction volume to fill the current blocks. But yeah, it's definitely more forward-looking. More future compatible.
Yeah, it's interesting. I mean, because if in Bitcoin land, the meme is kind of like that Bitcoin can scale and Monero can't, which is because which is it's kind of the opposite. So. Right. What do you think of then Bitcoin's approach with focusing on the second layer to where this for where they'll get their fungibility and also where they'll get their scale with things like the Lightning Network?
Yeah, see, that's okay. It's a simple principle of of software architecture or any architecture actually. If you don't have a good foundation, it doesn't matter what you try to build on top of it; it's going to collapse. With Bitcoin and the Lightning Network, if you imagine that Bitcoin's going to be the currency of the future for everyone, and you want 7 billion humans on Earth to be able to use it, it's going to take 550 years for 7 billion people to even create their very first transaction and open a Lightning channel. Okay. So saying that second layer scaling solutions will solve Bitcoin's problems is clearly false.
Could you wait? Could you? I saw you tweet that. Could you explain that a little bit more? Why would there be such a slow onboard time?
Well, it's simply that, every channel that opens has to be part of a mainnet Bitcoin transaction. Okay, and so again, if you're looking at 1 megabyte blocks and one block every 10 minutes, there's only so many people you can enroll in 24 hours or in 24 years. You certainly can't get 7 billion people on board all at once.
And then, so what is the reaction to that? I mean, that seems like a very plausible issue.
Well, there's certainly a lot of denialism. And I suppose there's some belief that not everybody needs to open their own channel. I'm not sure how that works, but I guess they assume that, for example, merchants will open a single channel that handles multiple customers, and okay, maybe that works, but to me, it still comes down to every individual who wants to use it has to have their own payment channel. Right? They have to be able to open it somehow.
Now, about for Monero? Do you think Monero should be looking at things like Lightning Network as well, or for the reasons you're talking about here, it's not really even something that should be considered?
I suppose there's probably no harm in it. Lightning Network on top of Monero would probably function better than it does on top of Bitcoin.
Yeah, can you explain? I've been asking that question as well. I'm curious what your reasoning is as to why that might be the case.
The people in the Bitcoin community talk about Lightning Network not only solving scaling problems, but also solving privacy problems. And, that's not really true, again, because you can monitor the coins entering and exiting the payment channels, all right? Whereas in Monero, all of those mainnet transactions are still opaque, so you can't actually see coins moving around. Right, so it's a better privacy solution on top of Monero than it would be on top of Bitcoin. Now, if you look at Monero usage today and the network today, we don't need it yet. We don't need that kind of a scaling solution yet, because the current network is doing just fine.
And then, so in terms of privacy, I get it. So we're going from a privacy at a core protocol level to now this second layer, so it's only going to help. But then how about in terms of the architecture as well? Because I mean, to run, what I don't understand is if you're running Lightning Network on the Bitcoin network, and the idea being, the lion's share of transaction volume will now be taking place on the second layer. How is mining going to continue to secure the blockchain if there's no incentive to mine, especially without something like a tail emission that Monero has?
Yeah, that's a really good question. If the majority of transactions are happening over Lightning, then right, miners aren't going to see those transaction fees. And obviously, when Bitcoin's emission ends, the miners are going to have no reason to participate at all. And at that point, the network is dead.
Yeah. So I mean, people in your echelon, I mean, what are the how are people responding to that?
Again, the only word that comes to mind is denialism. I think people aren't even looking at the problem. I mean, and I suppose in some ways, even if you're a Bitcoin developer and you're aware of the problem, your hands are tied, right? Because you have this this contract, this community contract that says this is what Bitcoin's emission is going to be, and you can't just go and change it now.
Right. So their hands are tied behind their back.
Yeah.
What do you think about Mimblewimble? Grin is implementing it, which doesn't yet exist, but And then, but it's also being talked about, I've heard it being talked about as potentially being used in conjunction with Monero as like on a side chain. Are these things you've ever looked at or considered?
I haven't really looked deeply into that. I've obviously heard people talking about that. It might be a good idea. But if you look at what Mimblewimble really offers, they claim that you can have a very lightweight blockchain because you don't have to keep historical blocks or something to that effect. And the reality is that's not entirely true. Somebody needs to be archiving this stuff. And the other part that goes with this is there's nothing preventing somebody from doing a full archive node. And if they do that, then they can de-anonymize what's going on the network. Okay, so Mimblewimble its privacy depends on the fact that everybody is pruning information all the time. If somebody decides not to prune, then they can actually break the privacy.
Yeah, I would like to do a show just on Mimblewimble. Try to kind of get to the bottom of that. What do you about Grin? What is your feeling of Grin? I mean, it's obviously just an implementation of Mimblewimble, but do you think this is kind of a project worth looking into? And
well,
it's getting a lot of attention.
I would say it's interesting to look at the technology. I have nothing to say about them until they've launched their mainnet.
Gotcha. What do you think of this other recent claim that's been going around by being pushed by the Bitcoin maximalists, basically that something like Monero requires more trust than something like Bitcoin, where everything is transparent. And, if there was some kind of emission bug or something, it would be completely obvious in Bitcoin as opposed to in Monero, where it may go undetected. So therefore, there being more trust in math and trust in the developers. Do you think there's any credit to that?
Yeah, that doesn't seem like a valid argument. If you look at there have been inflation bugs in the Monero code, and there have been bugs in the Bitcoin code. The Monero bug was detected before it was ever exploited on the net, which was a good thing. I think the point here is you have to know what you're looking for if you claim we could spot a bug like this faster on the Bitcoin network. All right, clearly, they didn't spot this one, and it's all about finding the bug in the code. They didn't see it on the network. Right. So I don't believe that the network transparency or opacity is really a factor here. It's all about, is there a bug in the implementation? Because we have to trust the math, right? And the math is sound in both of these cases, all right? So it really comes down to, was there a bug somewhere? And that's the same in any code base.
Right. So whether it's Bitcoin or Monero, you're trusting the math, and you're trusting there's some trust in the developers as well who are implementing it. There's really no difference. The math just might be a little bit more complicated in Monero.
Sure. Yeah.
So do you think there's any place for a coin like Bitcoin that is, transparent at its core? Do you think there's kind of there's utility there it's serving it will eventually serve a purpose that Monero can't fulfill? Or is it that if you built this core protocol like Monero and it works and it becomes large enough that it would be able to kind of not just do the privacy and fungible thing, but if you want, you could backstep and also, do the reveal, make it transparent as needed.
Yeah, I mean, Monero has optional transparency, and I think that's the right approach. Bitcoin and its derivatives and all the forks and clones based off of it, none of them behave like real money. Really what they behave like is a big surveillance machine. And no, I really don't see a valid use case for them anywhere. That's just not the way you want your money to behave.
Now, but from the standpoint of being a protocol, because you obviously are quite familiar with protocols, do you think this is a case where it makes sense for there to be one protocol that wins? One protocol on the internet that will be used for transferring value.
That's an interesting question. I think ultimately yes. It's like if you look at the way the internet has evolved, you can look at email protocols. There were 2 or 3 competing ones back in the dawn of time, and now there's just one SMTP, and that's used everywhere. And I think, yeah, for interoperability, for usability, you really only want to have one single protocol at the end of the day. It may not be Monero, it may be some new one that we haven't even seen yet, but I don't see a valid use case for like 5 or 10 running in parallel all the time.
Mm-hmm. Do you have any thoughts on whether or not, something like, Bitcoin, because it obviously has a first mover advantage, and maybe because it's more acceptable in the communities of governments, because the fact that it's transparent, so therefore maybe it won't be as susceptible to regulation, that maybe something like a Bitcoin has more of a chance of surviving for those reasons, and it's a good enough protocol. So even though it's not the best form of money transfer we can create on the internet, that maybe we'll just have to live with it, and that's the one that ultimately wins for those reasons.
I don't think a first mover advantage is any kind of guarantee. I mean, just today I was reminded of the existence of MySpace. When's the last time anybody thought about MySpace?
Mm-hmm.
Right. Yeah, first mover is not a guarantee. And as far as government regulation, that could go any number of ways. If you look at what's been happening in Europe with the GDPR, the General Data Protection Regulations, there's been a much stronger emphasis on consumer privacy in Europe, right? And if you put the current crop of crypto coins into that environment, you might find that Bitcoin and others won't pass muster for consumer privacy protection, and a coin like Monero would. So it's not obvious that when government regulation enters the scene that Bitcoin will be the obvious choice. It may not be.
That's an interesting take on it. Yeah, I think everybody has been looking at it from the flip side perspective, that it's more friendly to governments, but I guess it depends what government you're talking about, and
Yeah.
more progressive governments that are actually, taking a stance and starting to more highly consider, the need for privacy and in this digital age, may actually be more open to something that's protecting privacy on a protocol level.
Right.
That's an interesting take. So are there anything else that you're excited about in terms of development in Monero land, that's you kind of see on the horizon, things that you're working on? What is it that you kind of Google and follow, and what's your, other than the randomJS, what else is it that you're very interested in now in Monero?
Well, okay. I suppose the other things that occupy my time, obviously I spend a lot of time thinking about database work, and I look at what's coming out in new generations of ARM CPUs, new generations of AMD CPUs, and just looking at power efficiency, performance per watt, and those sorts of considerations.
Mm-hmm. What's your take on these proof of work coins use too much electricity and we're going to destroy the environment?
You know, that is something that kind of haunts me. I sit here and think, gosh, proof of work kind of sucks. It would be great if we had some other mechanism to protect and secure the network. I just don't know what that is yet.
And so, yeah, even with the randomJS, because when you mentioned that, if we eventually get to the point where ASICs kind of crack it, then that means there'd be a development in the JavaScript script world, which would be an additional benefit. So, are you thinking in those terms then with proof of work as well? Like, could it serve an additional use, or is that the nature of proof of work that it's just meant to be a big waste?
I think, yeah, it's the nature of proof of work that it's just meant to, consume resources, and that's the point that it makes it expensive for an attacker to try and subvert the network, right? Because you just got to deploy so many resources to be able to launch an attack. If you have a proof of work that has another useful function that starts to distort how strong it can be at protecting the network.
Mm-hmm. Mm-hmm. Okay. All right. That's really all I got. I mean, I crammed in a lot of questions there. Thank you.
Okay, sure.
And I know it's late where you are.
Yeah.
Thank you for, coming on the show. Thank you for taking your time. Thank you for doing it at this time. I know it's very late. Sorry, I was a little late. I was running from work. Really appreciate your time and your thoughtful answers.
All right. Thanks for having me on.
Thanks. I'll talk to you later.